Welcome to the plotting module of elementary statistics. In this module, we'll discuss histograms, frequency distributions, and stem and leaf plots. You will learn the characteristics of each chart type and how to build each chart type through an example. The importance of plots is shown here. Consider the exam scores for the following 25 students in a statistics class. How do you do it? There are 25 scores. Just glancing at the scores makes it difficult to understand how the scores are distributed. In the upper left corner, for example, I see some high values, 97, 88, 97, 85, another 88, but I also see low values scattered around as well, 58 in the upper left corner, or 49 in the lower right. Plots help us to discern trends and information about this data that is not evident by looking at a large list of data. The data we're considering is quantitative. It is one-way data, meaning that one variable only is considered. 4 plot types should jump to mind when you think about quantitative data: histograms, frequency distributions, stem and leaf plots, or box plots. We'll consider each of these plot types, but leave the box plot type for a later module. The following is a summary of the histogram, frequency distribution, and stem and leaf plot types. They're similar in many ways, but there are also differences. A histogram is a familiar bar graph. It's quick and easy to read and gives the best sense of the distribution of data. A frequency distribution shows quantitative or qualitative data. It helps one to understand trends going in a specific direction. And a stem and leaf plot is useful because it shows every data point. Each of the 3 plot types has some attributes in common. They all show quantitative data, and each buckets the data, meaning that it shows groups of data within a certain range of quantitative values. This helps to simplify the data set and summarize the trends in the data. It also shows aspects of the distribution, such as variability, skewness, or whether the data is skewed to one side or the other in the distribution, and modality, or the number of peaks in the distribution. Let's first consider a histogram and build a histogram for the student test score data. The first step is to identify the bucket width and center points for the data. Typically, 5 to 8 buckets is a good number of buckets to put in a histogram. We don't want so many buckets that the data is overwhelming. We want to simplify from the list. Looking at this data, we see that there is a minimum data point value of 48 and a maximum of 98. This gives us a range of 50. Let's select 6 buckets with a width of 10 and midpoints 45, 55, 65, etc. Since the midpoints are 45, 55, 65, etc., that means that the surrounding ranges for each bucket are about between 40 to 50, 50 to 60, etc. Now let's arrange all of the data by bucket. We know that the range for the buckets will be 40 to 50, 50 to 60, etc. I've color-coded each of the data points by bucket to simplify this process. For example, the yellow boxes show data that belongs in the bucket 40 to 50. The orange boxes show data that belongs in the bucket 50 to 60. The green boxes show data belonging in the bucket 60 to 70. The purple boxes show data belonging in the bucket 70 to 80. The brown boxes show data belonging in the bucket 80 to 90. And the blue boxes show data belonging in the bucket 90 to 100. Count the values in each bucket. This will define the bar height for the histogram bars. There are 2 values in each of the buckets, 40 to 50 and 50 to 60, and 3 values in each of the buckets, 60 to 70 and 70 to 80. There are 7 values in the bucket, 80 to 89, and 8 values in the bucket, 90 to 99. Now build the histogram by plotting bars for each bucket. The resulting histogram is shown below. Observe the center, skew, and variability of the data. The data is quite variable, and there's a strong skew in one direction. Most of the data is skewed toward the high end of the values. That is, most of the students scored in the 80s or 90s. The data is centered around a value of 80. Now let's consider this same data set for frequency distribution or frequency polygon. Again, we would identify the bucket width and center points. We selected 6 buckets with a width of 10 and midpoints of 45, 55, 65, etc. in the last case, and that worked out well. So let's do the same here. As a result, arranging the data by bucket gives the same color-coded map. And there are the same number of values in each bucket. Let's examine the frequency distribution or frequency polygon. Building the polygon, we draw a dot to represent the number of values in each bucket and then connect the dots with a line. Again, we see the same trends. The skewness is evident toward the high end of the set of exam scores. The data is also clearly quite variable. There are a number of people with low exam scores in the range of 40 to 70. Finally, consider a stem and leaf plot. For a stem and leaf plot, the width of the buckets is always 10, and the buckets are defined by the first numbers in the values in the data set. In this data set, the buckets are therefore 40 to 49, 50 to 59, etc. This is exactly the same set of buckets, by coincidence, as we used for the histogram and the frequency polygon. Therefore, our categories remain. The first step in building the stem and leaf plot is to draw the stem. The stem consists of listing the first numbers from lowest to highest in each bucket. In this case, we have values in the 40s, 50s, 60s, 70s, 80s, and 90s, so there are 4 numbers in the stem. After drawing the stem, list the final number for each data value alongside the appropriate bucket, increasing in value from left to right. For example, for the stem value of 4, there are 2 values in the bucket, 48 and 49. So we list an 8 and then a 9 alongside the stem. For the value 7, as another example, the values in the bucket are 76, 76, and 79. So we list 2 6s and a 9 alongside the stem. To summarize, histograms, frequency distributions, and stem and leaf plots can be used to plot the same type of data. The data plotted will be quantitative and divided into buckets, and each distribution type shows variability, skewness, and modality. We're familiar with a histogram as a bar graph that's seen in many periodicals in our day-to-day lives. It's quick and easy to read, and it gives the best sense of the distribution. A frequency distribution also shows quantitative data, but it can be used to show qualitative data as well. It's also good for looking at trends from one value to another, if the values on the x-axis are arranged in a specific direction. Finally, the stem and leaf plot shows every data point, so it can be used to understand exactly how the data set is distributed, in addition to giving a summary of the data set. This concludes our module on histograms, frequency distributions, and stem and leaf plots. Happy plotting. Welcome to the plotting module of elementary statistics. In this module, we'll discuss histograms, frequency distributions, and stem and leaf plots. You will learn the characteristics of each chart type and how to build each chart type through an example. The importance of plots is shown here. Consider the exam scores for the following 25 students in a statistics class. How do you do it? There are 25 scores.